Welcome back. During this portion of the webinar, we will be reviewing the quiz questions from experimental design. We're going to continue to follow the breakdown of the tool and move just a little faster than part 1. Ready to get started? Quiz question 1. What type of experimental design is displayed in the graph? Our answer choices include A, functional analysis, B, a multiple probe design, C, a changing criterion design, or D, an alternating treatments design. So let's get right into this question stem. What is this question asking us? This question provides a graph and asks the reader to demonstrate their understanding of experimental design. We have a shorter question stem, but what are the key words you guys identified here? Take a moment and see if you can find any. Ready? Our keywords are going to include experimental design and graph. So let's get into these a little bit more. Experimental design lets the reader know that they will need to use their knowledge of different experimental designs to determine the best fit for the displayed graph. And graph. So the graph displayed gives the reader information about the type of experimental design that's being utilized. So what concepts do we have to break down here? Let's talk about functional analysis, multiple probe design, changing criterion design, and alternating treatments design. So a functional analysis is an analysis of the functions of problem behavior as part of a functional behavior assessment. A functional analysis is a type of assessment procedure that is typically displayed in an alternating treatments design graph. A multiple probe design is an experimental design variation with the multiple baseline design that features intermittent measures or probes during baseline. A changing criterion design starts with an initial baseline phase, which is followed by a series of treatment phases consisting of successive and gradually changing criterion for reinforcement or punishment. And an alternating treatments design refers to an experimental design in which two or more conditions are presented in rapidly alternating succession, independent of the level of responding. So what are we thinking for question 1 after our quick review? Did you guys get A, B, C, or D for your answer? Ready to see? The correct answer is D. This is an alternating treatments design. Question 2. Based on the graph displayed above, what is the function of elopement? Our answer choices include A, automatic positive reinforcement, B, social positive reinforcement or attention, C, social negative reinforcement or escape demand, or D, tangible reinforcement. So let's get right into this question stem. So this question provides us with a graph and asks us to demonstrate our understanding of analyzing data. What keywords are going to help us analyze this data? What do you think? Ready? Our keywords here are going to be graph displayed and function of elopement. So let's talk about these. Graph displayed gives the reader information about the type of experimental design being utilized, the type of assessment being conducted, and the latency to response for the elopement behavior. Function of elopement lets the reader know that we will need to use our knowledge of analyzing data to determine the function of the elopement here. So let's review some of our concepts then. Let's talk about axes, automatic positive reinforcement, social positive reinforcement, social negative reinforcement, and tangible reinforcement. So axes. The graph displays data from a latency-based functional analysis. The y-axis on this graph represents latency, or the amount of time between the presentation of the SD and the onset of the behavior of interest. Automatic positive reinforcement is reinforcement that occurs independent of social mediation of others, like scratching an itch. In this graph, elopement did not occur in the control condition. Social positive reinforcement is behavior occurring to gain attention from others. In the graph, elopement occurred after only 10 to 100 seconds into that session start time. And social negative reinforcement, or behavior occurring to terminate or avoid unwanted interactions or demands. In the graph in the question, elopement either did not occur, so the data point was around 300 seconds, or it occurred between 250 and 270 seconds into the session. Tangible reinforcement is behavior that results in access to reinforcing materials or other stimuli. In the graph, the tangible condition was not assessed. So what do we think for question 2? Are we going to go with automatic positive, social negative, or tangible reinforcement? Ready to see your answer? The correct answer here is B, social positive reinforcement or attention. All right, question 3. An advantage to using single subject experimental design is A, studies are conducted with only one participant. B, average data in groups accounts for variability. C, each subject serves as its own control. Or D, objective data is not utilized. So what is this question asking us? We have a short question stem here, but that gives us information nonetheless. This question asks for the reader to identify key elements of single subject experimental design. This question requires the reader to apply their understanding of single subject experimental design when in comparison to group design elements or elements that may be false. So what did you guys get for key words? Take a moment and identify some now if you haven't already. Ready? Keywords in this question stem will include advantage and single subject experimental design. So what will these keywords tell us? Advantage lets us know that we will be looking for the best matching advantage that matches single subject experimental design. And single subject experimental design lets the reader know the term that is being identified. So let's break down some of these concepts of single subject experimental design. Single subject design does use multiple participants and does not conduct studies with only one participant. When an experimenter averages data in groups to account for variability, they are conducting a group design. Group design involves randomly assigning participants to 2 or more groups with at least one treatment group and one control group where the data are compared across groups. When using single subject design, each subject serves as its own control and is an advantage over group design, which averages performance across multiple participants. And stating that objective data is not utilized is also not an advantage of single subject design. Objective data is used in single subject design and is an advantage. So what are we thinking for question 3? Studies are conducted with only one participant. Average data in groups accounts for variability. Each subject serves as its own control, or objective data is not utilized. Ready to see the correct answer? An advantage to using single subject experimental design is that each subject serves as its own control. Answer C. All right, question 4. Based on the graph displayed above, what is the best criterion for change? Our answer choices are A, maintain 40 seconds until stable responding. B, do a reversal design or return to baseline. C, 45 seconds, or D, 80 seconds. So let's break down this question stem. This question provides the reader a graph and asks the reader to demonstrate their understanding of changing criterion design. So what keywords did you identify here to help lead you to the correct answer? Take a moment and see if you can identify any now. Ready? Keywords here are going to include graph displayed and next best criterion change. So graph displayed, this is going to tell us that the graph displayed gives us information about the type of experimental design being utilized and the magnitude of criterion changes. Next best criterion change lets the reader know that they will need to use their knowledge of analyzing data to determine the next criterion phase that should be implemented. So what concepts do we have here? Let's talk about our answer set. If we maintain 40 seconds until stable responding, we would do that if variable responding was observed in the data graphed. Based on the graph provided, stable responding has already been met. A reversal design or returning to baseline, this could demonstrate experimental control, but is not necessary when implementing a changing criterion design. Increasing to 45 seconds does not really match the previous increases that we've seen on the graph, so that may be too small of a step increase in comparison to the previous changes in criterion. The BCBA may choose to increase to 80 seconds because it does double the previous criterion, which does match previous step increases in that same graph. So what do we think for question 4? Should we maintain for 40 seconds, do a reversal design, do a 45-second increase, or an 80-second increase? What did you guys get for answer number 4? Ready? The correct answer is D, 80 seconds. All right, let's move on to question 5. How's everyone doing? Doing well so far? All right. What type of experimental design is displayed above? Our answer choices include A, a multiple probe design across behaviors, B, a multiple baseline design across behaviors, C, a multiple baseline design across environments, or D, a multiple probe design across environments. So let's get right into this question stem. This question provides a graph and asks the reader to demonstrate their understanding of experimental design. What keywords did you guys identify in this question stem while you were taking your quiz? What do you think? Ready? Keywords here are going to be experimental design and the graph display. So let's talk about it a little bit more. Graph displayed is going to give the reader information about the type of experimental design being utilized. Experimental design lets us know that we will need to use our knowledge of different experimental designs to determine the best fit for the displayed graph. So let's break down the concepts. A multiple probe design across behaviors is going to feature intermittent measures or probes during baseline. A multiple baseline design across behaviors is collecting concurrent measurement of 2 or more behaviors in a baseline condition, followed by application of an independent variable to one of the behaviors in baseline, while baseline conditions remain in effect for the other behaviors. A multiple baseline design across environments is when a treatment variable is applied to the same behavior of the same participant across 2 or more different settings, situations, or time periods using concurrent measurement throughout baseline and treatment. And a multiple probe design across environments is applying the treatment variables across settings, situations, or time periods using intermittent measures or probes during baseline. So what are we thinking for question 5? What type of experimental design do we have here? Multiple probe across behaviors, multiple baseline across behaviors, multiple baseline across environments, multiple probe across environments. What did you guys get? The correct answer is A. This is a multiple probe design across behaviors. All right, question 6. If a BCBA were presenting this graph in a team meeting, how would the BCBA best orient an observer to this graph when describing the x-axis, the y-axis, the dependent variable, and the independent variable? Our answer choices include A, the x-axis is sessions, the y-axis is responding per hour spitting, the dependent variable is the DRA, and the independent variable is spitting. B, the x-axis is sessions, the y-axis is responses per hour spitting, the dependent variable is spitting, and the independent variable is the DRA. C, the x-axis is responses per hour spitting, the y-axis is sessions, the dependent variable is spitting, and the independent variable is the DRA. Or D, the x-axis is responses per hour spitting, the y-axis is sessions, the dependent variable is the DRA, and the independent variable is spitting. So let's get into it. What is this question stem asking us? So in this question, we are provided a graph and asked to demonstrate our ability to explain all variables of the graph, including the x and y axis, the independent and the dependent variables. This requires the reader to understand each of the 4 concepts being asked. All response choices relate to the graph displayed and the 4 areas of the graph being asked to explain. So the question is asking the reader to demonstrate their understanding of independent and dependent variables as well as interpret the data displayed. So what keywords did you guys identify in this question stem while you were taking your quiz? Take a moment and see if you can identify any now if you haven't already. Ready? Our keywords are going to be graph, best-oriented observer, describe the x-axis, the y-axis, the dependent variable, and the independent variable. So let's break these down a little bit more, starting with graph. The graph displayed gives the reader information about the type of experimental design being utilized. The graph also displays information about responses per hour across alternating conditions. Oriented observer, this informs us on the expectation of helping an observer understand the graph as if the reader is presenting the graph to others. Describe the x and y axis, dependent variables, and independent variables. So this informs the reader on what information should be provided during the presentation of this graph to others. So what concepts do we have to review? We've got the x and y axis. So the x-axis is the horizontal axis on the graph along the bottom, which often represents time. The y-axis is the vertical axis on the graph that runs up and down and will often represent information about responding, so frequency, rate, percent, duration. And the dependent and independent variables. So the dependent variable is the variable in an experiment measured to determine if it changes as a result of manipulations of the independent variable. The independent variable, then, is the variable that is systematically manipulated by the researcher in an experiment to see whether changes in the independent variable produce reliable changes in the dependent variable. So what do we think for question 6? What is the most accurate way to describe this graph? Answer A, B, C, or D. What did you guys get? Ready? The correct answer is B. The x-axis is sessions, the y-axis is responses per hour spitting, the dependent variable is spitting, and the independent variable is the DRA. All right, question 7, second to last. A BCBA collects baseline data on elopement behavior. Once stable responding is seen, the BCBA introduces a behavior plan and a decrease in elopement behavior is demonstrated. Next, the BCBA would like to demonstrate internal validity. The best way for the BCBA to demonstrate internal validity is to A, introduce the same behavior plan to another client, B, check that caregivers are satisfied with the effect on elopement behavior, C, return to baseline, or D, conduct procedural fidelity checks. So what is this question stem asking us? Let's break this down. So this question asks the reader to utilize their understanding of demonstrating internal validity when given an example in an applied setting of behavior analysis. What keywords did you guys identify in this question stem? Take a moment and see if you can find any if you haven't already. Ready? We finally have a longer question stem, so we have lots of keywords in this one. Keywords will be baseline data, stable responding, introduces a behavior plan, decreases in elopement, demonstrate internal validity, and internal validity. So let's break these down a little bit more. Baseline data and stable responding will let the reader know that initial data were collected. Introduces a behavior plan and decreases in elopement let us know that there has been change in behavior observed. Demonstrate internal validity then lets us know that we will need to identify the next step the BCBA should take to demonstrate internal validity. So let's talk about some of these concepts of fidelity and validity. So introducing the same behavior plan to another client is an example of external validity. Checking that caregivers are satisfied with the effect on elopement behavior is a demonstration of social validity. Returning to baseline is an example of internal validity because the behavior analyst is demonstrating the change in behavior is a function of the independent variable or the behavior plan, and not a result of uncontrolled or unknown variables, and the BCBA is demonstrating replication. If the BCBA were checking for procedural fidelity, they would conduct procedural fidelity checks on the implementation of all conditions that were implemented to ensure they were implemented correctly. So what do we think for question 7? The best way for this BCBA to demonstrate internal validity is to A, introduce the same behavior plan with another client, B, check that caregivers are satisfied, C, return to baseline, or D, conduct a procedural fidelity check. What do you guys think? Ready? The correct answer is C. We want to return to baseline here. All right, we made it to our last question, quiz question 8. Which of these choices is not a reason for conducting a component analysis of a treatment package? Our answer choices are A, determine what combinations of a treatment package improve responding, B, determine the different effects of a range of values on a treatment package, C, determine what individual component of the treatment package improves responding, or D, all of the above are reasons to conduct a component analysis. So let's break down this question stem one last time. So this question is asking the reader to identify the rationale for conducting a component analysis and what does not fit as rationale for conducting a component analysis. What keywords did you guys identify here? What do you think? I'm thinking not a reason in component analysis. So how will these help us? Not a reason. This orients the reader to identify the answer choice that does not match the rationale for conducting a component analysis. In component analysis informs the reader of what type of experimental design they will need to identify from the answer choices. So let's review these concepts. A component analysis identifies active elements of a treatment condition or intervention package which aids in determining relative contributions of different variables in the treatment package and or the necessary and sufficient components of an intervention. A component analysis is conducted to determine what combinations of treatment packages improve responding and determine what individual component of the treatment package improves responding. So if the behavior analyst is trying to determine the different effects of a range of values of a treatment package, they're conducting a parametric analysis. When using a parametric design, the experimental design is utilized to demonstrate the differential effects of a range of values of an independent variable. So all of the above are reasons to conduct a component analysis is not really the best answer choice because one answer choice does not fit with the rationale for conducting a component analysis. So what do we think? Which of these is not a reason for conducting a component analysis of a treatment package? To determine what combinations improve responding, to determine differential effects, to determine individual components, or all of the above. Ready? The correct answer is B, to determine the differential effects of a range of values of a treatment package. Some tips and reminders for you guys to take with you. Be prepared to conduct visual analysis on a variety of experimental designs. Also, be prepared to derive solutions based on the relevant information. Finding those keywords is helpful. And then look closely at your X and Y axis labels. All right, guys, thank you for joining us and good luck.